So systems of linear equations in two variables. So first off, let's talk about what these are. So literally, linear equations, lines, two variables, means that the lines are not going to be just perpendicular or horizontal, horizontal or vertical. So we're going to have an x and a y in them. And the way that we can solve systems of linear equations is they can cross, and this one point right here would be the answer, because this one point would be true for both equations. So if we had the point, well, we'll just do one in a minute. The lines could be parallel, which means they never, ever, ever cross. So you're not going to have any solution because there's nothing in common with the two. Or they could be the exact same line on top of each other. If they're the exact same line on top of each other, there's going to be infinitely many solutions, but that's different than saying how before we said all real x's would work. We have infinitely many solutions, but it's all the solutions to one of the equations. So it's that line, all the solutions for that line would be the solution for the system of equations. We'll do them. It'll make more sense, I promise. So we'll have exactly one where we'll give the ordered pair. We'll say that there's no solution and that they're parallel. Or we'll say that there's infinitely many solutions because it's the same line is fine. Or you can say line coincides or lines coincide, but same line works. All right. So we're going to solve by the addition method. The goal of the addition method is to have it whenever you add straight down, one of the variables will go away. The first one is super nice and easy. Because if we add straight down, you guys see the positive 3y, the negative 3y, they're going to definitely cancel out. So we're literally adding straight down. So we get 4x because 2x plus 2x. The 3y minus 3y is going to give us nothing, so I'm going to leave a little blank, equals, and then 6 plus 6 gives us 12. So now we've got 4x equals 12. Divide both sides by 4, and we get x equals 3. We are not done, okay? This is a system of equations. It's got an x and a y. So far, we know that our solution, the x is 3. We have to figure out what the y is. So to figure it out, all we have to do is plug it back in. Plug x equals 3 into either equation, and if you want to double check, plug it into both equations. So 2 times 3 plus 3y is 6. So 6 plus 3y is 6. Subtract 6. 3y is 0. So we get y is 0. So our solution for this system of equations is 3, 0. So at 3, 0, these guys cross each other. Yeah, there's a way in there too. However, be aware, even though your calculator will do it, I might not ask you for the answer. I might ask you which of these is a valid step. So make sure you know how to do it by hand. If we want to double check, because I use this top equation to solve for my y, I'm going to look at the second equation with a 3 for my x and a 0 for my y to see if I get a true statement, which I do. 2 times 3 gives us 6, minus 3 times 0 is 0. So 6 minus 0 is 0. 6 minus 0 is 6. True statement. So we can kind of double check here. All right, for b, if we look, we cannot just add straight down and get things to cancel. But keeping in mind that if we do the same thing to both sides of an equation, it's still the equivalent. So I see that I have a negative 4 here and a positive 1 here. So if I multiply that top by 4, then my x's will cancel. So what I'm going to choose to do is take this top equation and multiply it by 4. Whenever I do that, I'm going to get 4x plus 8y equals 8. So you've got to multiply all pieces by that 4. And then I'm going to just rewrite the second equation right underneath. I'm not going to change it. And now I can add straight down, and my x's are going to cancel, which is what I was going for. Yes?
The
Uh-huh. Because if I'd multiplied by -4, whenever I added straight down, I would have gotten -8x. And I need to make sure they cancel whenever you add down. So to make sure they cancel, I have to have opposite signs. So adding these down, the 4x and -4x cancel. The 8y plus 3y is going to give us 11y. And the 8 plus 25 is going to give us 33. Divide both sides by 11. We get y is 3. So for this one, so far, we've got this part. So we got the y is 3, and we need to solve for the x. So we can plug this into either equation. I'm going to pick the x plus 2y equals 2 because it looks easier. So x plus 2, plug in that 3 for the y, equals 2. So we have x plus 6 is 2. Subtract 6 on both sides, and we get x equals -4.
When you plug it in, do you plug it in to the original equation or to the one you distributed?
My suggestion is to pick the original. The reason being is there's no way you mess that one up. And if you, anyways, where you would be more likely to catch a mistake. So is everybody okay? The solution for this one's going to be -4, 3? Yeah. And if you want to double check, let's see, -4 times -4 is going to give you a positive 16. And then plus 3 times 3 is 9. So that's 16 plus 9 is 25. So that's true. And all I'm doing is just mentally plugging the solution in the second equation. And again, your calculator's great at it if you can't just think through it. I've been practicing a lot longer. Okay, for C. C is a little bit tricky because it's not set up in the same form. So we want to get our x's, then our y's equals a number. So for this one, I'm going to go ahead and move this 4y over. So whenever I move the 4y over, it becomes -4y. So we've got 3x minus 4y equals 1. So that's the first equation with me just moving the y over. And now I'm going to move this 4x over. So whenever I move the 4x over for the second equation, it becomes positive. So we have a positive 4x plus 3y equals 1. All right, now looking at this, I don't have a really easy way to cancel my x's or my y's. I can't multiply one equation by a number, or I can't, well, I can, but I can't multiply one equation by a number that's easy and get them to cancel. So we're going to have to multiply both equations. Whenever I'm looking, I see that I have a -4y and a positive 3y. So I have those opposite signs. If those opposite signs are already there, then I know I can just multiply by positives if that's the variable I want to cancel. So that's how I'm going to pinpoint to cancel out the y's. But if we wanted to cancel the x's, we could multiply by a -4 and a positive 3 or something like that. I'm choosing the one with the opposite sign so that we're multiplying by positives. But again, there's a lot of ways to do this one. All right, so on top, we're going to multiply by 3. So that's going to give us 9x minus 12y equals 3. And on the next one, we're going to multiply by 4. And that's going to give us 16x plus 12y equals 4. And if we add straight down, the 12y's are going to cancel. We have 9x plus 16x, which is going to give us what? 25x equals 7. And then divide both sides by 25. So we have x equals 7 over 25. So far for our solution, we have 7/25, comma something. All right, so we can take this x equals 7/25, plug it back in and solve. But what I'm going to actually do since I know everybody loves fractions, is I'm going to go through and I'm going to start with the 3x minus 4y equals 1. And the 4x plus 3y equals 1. And we got the y's to cancel, now I'm going to get the x's to cancel. So we are going to go ahead and multiply by a negative. I was trying to avoid it, but good practice. So I'm going to multiply the top by 4. And I'll multiply that bottom equation by a negative 3. You can. You completely can. The only reason I'm not is because it's 7 over 25, and I know you guys hate fractions. You guys tend to freak out about them. But yes, you can definitely just plug that x equals 7 over 7/25 back in and get the right answer. If I go through and distribute here, we're going to get 12x minus 16y equals 1. And negative 12x minus 9y. Oh, did you see what I did? Yeah. There we go. All right, add straight down. X's cancel. We get a negative 25y equals 1. Divide both sides by negative 25. So we got y is 1/25. Oh, negative, yes. I almost did the thing I always accuse you guys of doing. I almost forgot my sign. But whenever I plugged it back in and had my calculator do it, I would have hopefully caught the negative. Hopefully. Is that okay? You guys feel all right about the addition method? Uh-huh. I just made them up. I was coming up with something that I could multiply these by and get them to cancel. So I sort of thought about it as a least common denominator, I guess. So where if I have a 3 and a 4, I know that 12 will get me there. But I need to have one positive, one negative. So whenever I add straight down, they cancel. So on top, I chose to make positive. I could have done a negative 4 and a positive 3. That would have been fine. But I needed to get to 12, and I needed to have one of them negative. Right, this is if I wanted to do substitution twice. Yeah, we could have plugged this back in from the beginning and then still gotten the same answer. Uh-huh, yes. So substitution, if we had taken this part, I'm going to plug it in the second equation. So we would have had 3y equals 1 minus 4 onto 7/25. So we got 3y equals 1 minus, and this will be a negative 28/25. That okay? 4 times the 7 gives us a negative 28. So this is a 3y equals, so this is 1 minus 28/25. 1 is the same as 25/25, right? So 25/25 minus 28/25 is going to give us a negative, negative 3/25. And then we have to divide both sides by 3. Instead of dividing by 3, I'm going to multiply by 1/3. It is the exact same thing. So I'm going to multiply by 1/3 because I think that's just a little shorter. Do you guys see that that's the same? Exactly. And then these go away, and we're left with a negative 1/25. So you'll still get there. Whenever you go plug back in, try to pick an original. Yeah. Is that okay? So we accidentally skipped it. We're doing it now. So I thought we were almost done. We were not. I lied. Substitution method. Super easy. Instead of us substituting in a value like we were just doing with the addition method, we went through, we solved for x, we plug in whatever number x is, we get y. Well, instead of having like x equals 2 or y equals 3 to substitute in, it's telling us y is the same as 3x. So if you already have y equals or x equals, then substitute that into the other equation. So I'm going to substitute y equals 3x into this top equation. This top equation is x plus y equals 4. Instead of the y, I'm putting the 3x. So now I have x plus 3x is 4. So 4x is 4. Divide. X is 1. So for our solution, we know that x is 1. And then we just plug in. And this is the easy one, right? Y equals 3 times x. Yeah. So y equals 3. And then for that x, plug in the 1. Oh, so y is 3. Super done quick. Let's do it again. All right, and again, they were nice enough to go ahead and solve for one of the variables for you. So they already said y equals 2x plus 7. So I'm going to rewrite this top one, and instead of the y, I'm going to leave parentheses. So we've got 2x minus 3 times y, but instead of the y, I'm leaving parentheses, equals negative 13. I'm going to substitute in this 2x plus 7 because that's the same thing as y, exact same thing. We're going to go ahead and just crunch through it like we were with everything else. So distribute that negative 3. I'm going to combine like terms. We've got negative 4x minus 21 equals negative 13. Add 21 to both sides. So negative 4x equals positive 8. And divide both sides by negative 4. So we get x is negative 2? All right. So far, we know that the x is negative 2. By the way, as soon as I'm getting a variable, I'm going ahead and putting it in that part of the ordered pair. I suggest you do that just because I've seen people go through, get the right answers, and put them in backwards. So as you get them, I suggest it. You don't have to. All right, then we're going to substitute in. So we have y equals 2 times x. X is negative 2. And then plus 7. So y is negative 4 plus 7. So y is 3. Is that okay? For C, I would suggest clearing, right? You can multiply everything by 6 to get rid of the fractions, and then doing substitution. So I'm going to clear this just to make it prettier and nicer. So if we multiply everything by 6, and we'll see how this goes if you're okay with this. So the 6 times x over 6 gives us just x. And then minus 6 times y over 2 is going to give us 3y equals 6 times 1/3 is just going to give us 2. Is that okay? All right, good. So that's the first equation. And I'm just going to, I'm going to go ahead and solve for x in this first equation. Just because I think it's nice and pretty, right? So I want to solve for x because I'm going to use the substitution method. So if I add 3y to both sides, then I'm going to get x equals 3y plus 2. And besides, we solve for y in the other ones. So x equals 3y plus 2. That is from the first equation. So I'm going to plug that into the second equation. So the second equation, I have x plus 2y equals negative 3. And instead of this x, I'm now going to plug in this 3y plus 2. So I got 3y and 2y, so 5y plus 2 equals negative 3. Subtract 2 on both sides. Yeah. So 5y is negative 5, y is negative 1. And I can't actually fit all this in here. Here we go. Solution. So far, I know negative 1 for the y. So I just need to plug in and solve because I can see that second equation. I'm going to choose that one. So we have x plus 2 times y is negative 3. I'm going to plug in that negative 1. So x minus 2 equals negative 3. Add 2 to both sides. X equals negative 1. So our solution was negative 1, negative 1. And if we want to plug back into the top, we would have 1/6 plus 1/2 equals 1/3. So, sorry, negative 1/6 plus 1/2 equals 1/3, which is true. Your calculator will verify it for you. So continuing on with solving systems of linear equations in two variables, so far all the examples we've looked at have been like this, where it's been a solution of an ordered pair because the two lines are crossing in one point. Let's look at some other examples. So we're going to solve these systems of linear equations, and we can either use the substitution method or the addition method. Because it's already set up where we have y equals, that's going to make substitution really easy. So we'll substitute this first equation into the second. So we keep 21x minus 35 equals 7, and then we're going to plug the y in. So instead of y, we're now going to write 3x minus 5. So we have 21x minus 35 equals, and then distribute, and we're going to get 21x minus 35. So whenever you may notice at this point that we have the exact same thing on both sides, but just in case you don't, we can move that 21x over, and we're going to get negative 35 equals negative 35. This is always true. If it doesn't occur to you that we have something that's always true, and you go ahead and move the 35, that's fine also. So plus 35 on both sides. And we end up with 0 equals 0. So here or here would have been the most likely places that we would have noticed our variables canceled. Because our variables completely canceled and we ended up with a true statement, that means we're going to have infinitely many solutions. The reason we're going to have infinitely many solutions is because these are the same line or coinciding lines. So it would be like this picture over here where it's two lines on top of each other. All right, let's work out the second example. Again, because we have y equals, we're going to use the substitution method because it'll be easy. So we're going to plug the second equation into the first. So instead of 2y, we're going to have 2 and then on to 2 minus 3x. So we have 6x, and we need to distribute, plus 4 minus 6x equals 7. Combining like terms leaves us with 4 equals 7. Hopefully at this point you realize something's weird because our variables have canceled and we have a false statement. If not, it's okay to move your 7 over. So we're going to have negative 3 equals 0. And again, these are still false statements. The variables are definitely gone. They've canceled out. Because we end up with a false statement, this is going to be no solution. The reason this has no solution is because these are parallel lines that never intersect.